welcome. Thank you for joining us today on this. At least it's a nice hot Thursday here in upstate New York. My name is Greg Marcoux. I'm one of the assistant directors of admission here at Rensselaer. I want to welcome you all to our information session about civil and environmental engineering at Rensselaer. I'm going to give you a quick couple of housekeeping notes, and then we'll pass it off to my colleagues in engineering. If you have any questions, feel free to submit them in the chat feature on the left side of the screen. It is a moderated chat, so we're going to answer one question at a time just to keep it a little less confusing and say that you see question, answer, question, answer. If there's any specific questions that I may think are more relevant for my colleagues in engineering to answer, I will hold those until the end when we get to the Q&A portion, but I'll answer a few throughout the session as well. So again, if you have any questions, feel free to submit them in the chat, and at this point, I will pass it off to Dr. Uchuda.
Hello, thanks, Greg. Hello, everyone. This is Civil and Environment Engineering Department. I'm representing Civil and Environment Engineering Department. My name is Shinu Uchida. I'm professor in Civil and Environment Engineering, and I'm with the head of department as well, Chris Litchford. And so we're going to answer your questions. And before that, we're going to explain why you should choose us. Because my internet is not very fast, I cannot really put the video on, but I'm put my photo here. So here, that's me, that's Shinu Uchida. Right, before starting to detail, okay, yes. So this is the contents of today's talk. So I'm going to tell you 3 reasons why Civil and Environment Engineering at the Rensselaer Polytechnic Institute is the best choice for you. And there are 3 reasons. One is history. We are 196 years old, soon to be 97. And resources, we have lab facilities, ASC student chapter. ASC stands for American Society of Civil Engineers. And third reason, which is probably the most important one, is world-leading experts. So I'm going to go to details one by one. And before that, if you have any questions, like Greg said, please type in the chat box anytime. And Greg will answer the admin-related questions. And I and Chris Litchford will answer civil and environment engineering-related questions at the end. Okay? Right. Okay, so let's start with the first reason why you should choose us. That was history. The reason number 1, history. We are the oldest technological university in English-speaking countries, founded in 1824. So we are because of that long history, we are the first civil engineering degree in the US. So before us, there's no civil engineers in the United States. So we are also first environmental engineering degrees in the world. So before us, there's no environmental engineers in the world. So we have a very, very old, long-standing histories and reputations. And because of the history, this is where our president, Dr. Jackson, lives now, but he used to belong to us, Civil and Environment Engineering Department. So this is very nice. I mean, like today, it's be very, very beautiful weather. So if you come here around this time, you can see this beautiful campus, and this is where President Jackson stays. And that building used to belong to us, and this is a map of RPI, and that building has this column saying civil and environment engineering, or civil engineering actually, because we started as a civil engineering. So this is the soil column, so concrete column is etched as a civil engineering. And because of that long history, what we have is we have a lot of very, very famous alumni in the world. One of them, I'm just listing 4 of them, but then with many more. And one of them is George W. Ferris, who's the inventor of Ferris wheel. So if you see all those Ferris wheels, and he's from us. Second person, second to the right, top right, Ralph Peck. He's very special to me because I do what we call geotechnical engineering. It's part of civil engineering. And geotechnical engineering started with a person called Carl Terzaghi, who's the father of soil mechanics. And Ralph Peck served him very well. So he's a son of a geotechnical engineer. And he's from us. He's from RPI. The third bottom left is Seijiro Hirai, who studied transportation engineering and railway engineering at RPI and went to Japan, and he's invented this very nice system of railway in Japan. If you haven't been to Japan, you should check how punctual the train is and how well organized, how clean, how nicely organized the railway systems in Japan. So there's big news the other day. It was not long time ago, about a month ago. Train was late about 1 minute, and that was news in Japan. So that's how punctual it is, and that's coming from our alumni, RPI alumni, Seijiro Hirai. Bottom right is Washington Moobling, who built Brooklyn Bridge. And a Brooklyn Bridge is they renovated, but there's an old piece of part of Brooklyn Bridge. It stays at our department. So if you come here, you can see the part of the Brooklyn Bridge at the Civil Environment Department here at RPI. Right, so because of the long history, what long history brings, and one is recognition. Because of the long history, because of very, very famous alumni, and like I said, there's no civil and environment engineers before us. So we sort of started those organizations or civil and environment engineering in the world, or in the US at least. So many civil and environmental engineers know us. So we are recognized both nationally and internationally. And another thing long history brings is connection. We are very, very strongly tied with the civil and environmental communities locally, not just locally, nationally, and also worldwide. Because of long history, because of many, many famous alumni, because a lot of graduates are doing great job, we have a strong connection. So you will have many opportunities to meet and collaborate or work with them and make connections with the practicing engineers and to intern for them. So which is part of the process of learning how civil engineering does. So you can do intern very easily here at RPI. And the third reason what long history brings is this: stability. We have contributed to society for a long time and continue to do so. So long-standing RPI Civil and Environment Engineering Alumni Network is not going to disappear. I know at the moment, we live in very, very uncertain situations, but this long history stays. Why? Because we were here before and here now, and will be in the future as well, because that long history guarantees that we're going to be here. So this is really rings very important message. Because of the long history, we are very, very strong and we're very stable. So we should consider us going nowhere. We are staying here. There's a very nice articles about us, and then there's so you can use this QPR. You can scan this QPR code and then go to this article, which is written by Richard, and he stated that, he wrote that, and then he interviewed someone very famous, and so this person said, they as in us, RPI built America. That might be a stretch, but not too much of a stretch of statement. Why? Because before us, there's no civil engineers, civil and environment engineers before us. So we built America. Right, so history, part of the history, you will become part of our long history. So RPI brand is as important as civil and environment engineering degree itself. You are going, if you're thinking of coming in here, you are going to get a civil and environmental engineering degree. But degree is important, but coming or graduating from RPI is a very, very important brand as well. So that's the first reason why you need to choose us, or you should choose us. Long history. Right, moving on to the second reason, and this is going to be sort of what we're going to do here. Reason number 2, resources. First reason is first of the resources, the state-of-the-art research facilities. We have very nice geotechnical centrifuge. What centrifuge does is they spin, and because I do geotechnical engineering, let me explain what they do. What's so special about this? The behavior of geotechnical engineering, behavior of soil, is governed by the gravity, and how deep it is very, very important, because that's what soil carries. But if we want to understand the behavior of soil under 10 meters deep, you need to build 10 meters of soil column, the huge, which is practically impossible. So what we're going to do is we're going to spin and we increase gravity. Let's say if we increase gravity 100 times, then we can model 10 meter deep soil by 10 centimeter of soil column. So you can scale it down. So this is very, very important tool to make it possible for us to understand soil behavior. And in the world, there are about 20 or something like 30 centrifuge. And I'm biased, but this is the best. This is the best centrifuge. And then you have a chance to touch this. So you have a chance to not play, but then study, do tiny bit of a study with it. And other resources, we have hydraulic flume and earthquake shake tables. We are very famous for earthquakes in dunes, and we started doing this fluid mechanics in a very, very hands-on experiments as well, which is part of the learning process. So you really have to have experimental apparatus to understand the behavior. And we have very, very nice facilities here, state-of-the-art facilities. These facilities have helped us conducting world-leading research, us professors doing world-leading research, and you'll use these in your design class, applying fundamental principles for engineering solutions. So not just learning at the class, you go to the lab and then touch those facilities, use these facilities and understand real behavior. So next page, I'm going to show you QR code. I cannot really go through. If it's normal circumstances, you can come here and then do laptop tour, but not today. So I'm showing this QR code, and if you scan it, it jumps to one of those web pages, so you can do a quick tour, virtual tour by video. Sorry, and then you don't have to do that now, so let's move on. So the slide will be shared, so you can go to those links, and then I do a lab tour. Please do. Right, and then because of the long history and because of the resources, this is one of the very important resources as well. Because of our long history, American Society of Civil Engineers, ASCE, awarded a student chapter, and we are one of the leading ones. So we're recognized by the society, and we have a student chapter which is run by students. So a student organizes events, and the student invites professional engineers to give a talk or have a chance to mingle with those people. So it's very, very nicely organized. It's not just society, our students are doing a great job, which is the next slide. We won GeoWall competition in 2020. So we have very good students and a very nice chapter, ASC chapter, and we are leading, yes. And another resource is at the campus. This is the RPI itself, not specifically civil and environmental engineering, but the RPI has a very, very nice resources and lots of resources. For example, academic and personal support. We have a hub, class deans, and ALAC. ALAC is tutoring service. And this is part of the why you want to go to university. Second reason, second point is clubs, sports, and activities. You become very good friends with lots of people from different backgrounds, or people who are learning different subjects, but you do the same clubs and sports and activities. The third reason, if you're interested in doing research, you have opportunities to do research, what we call undergraduate research, which I'm going to explain in a couple of slides and very briefly. And the fourth are the services, shops, and libraries and computing offices. Shop isn't open at the moment, but then it will open very soon once we become back to normal circumstances. Right, so to wrap up the second reason, your time here will be full of exciting activities supported by advanced facilities like I showed, and also advising resources from the university, RPI itself, and a variety of clubs. So we have lots of resources, so this is the number 2 reasons. Right, let's move on to the final, not the least reason, which are the people. So I'm going to introduce those people very briefly and what they do. The top is Chris Letchford, the head of a department. He's not just a head of a department, he teaches structural engineering. So we have structural engineering, transportation engineering, and environmental engineering, and geotechnical engineering, and I'll show you who they are in a minute. These four people, starting with Chris Letchford, are structural engineers who teaches structural engineering. And we have these people very, very famous internationally, nationally, and internationally. For example, locally in the region-wise, we have lots of snow, so we have this snow load expert, Michael Roque, and we have a big shake table studying about earthquakes engineering, and we have very big projects all the time. And these are world leading, it's all recognized by many people. Then second one is a transportation engineering. These are four professors leading that transportation engineering. The Jose is very, very famous. He has two centers. One is smart transportation system centers, and the other is this sustainable urban freight systems. Transportation engineer, we are very, very good at controlling transportation, not just understanding transportation itself, but flow. We are trying to understand the flow of people, flow of object, flow of freights as well. And third one, environment engineering. We have three professors teaching that and leading that project, and it's a world leading as well. We have especially remediation, environmental chemistry. We have water purification. We have stormwater control. Water is a big issue in civil and environment engineering, and it's access to water is probably the key for the next 20, 50 years, and we lead in that. Later on, I'm gonna give you the email address so you can ask those professors what we actually do. But in a very short term, we do a very, very good job to protect our environment. And we have lots of famous alumni as well. Right, and then geotechnical engineering, which is what I do, and I have 6 other professors, colleagues teaching geotechnical engineering and doing geotechnical engineering related research. One of those river levee monitoring or energy geotechnics, and then centrifuge as well. What I do is energy geotechnics. I work with the Department of Energy, looking at oil and gas and things like that. Right, so if you're interested, please contact us. So these are email address if you're interested in doing research, undergraduate research, or if you want to know what kind of research we specifically do, or what kind of world-reading research we do, you can contact these professors. If you're interested in structural engineering, Professor Letchford is here, so he can answer your questions as well. If you have specific question about transportation engineering, you can ask Professor Hare, and environment engineering, Professor Kildoff. And if you have a question about geotechnical engineering, just ask me. I can answer that. Right. So these are third reason why you should choose RPI. But the most importantly, or the reason I really strongly recommend that you should consider coming here is following. I've been at 5 different universities in 5 different countries. Professor Letchford, actually, he's gone to, I don't know, 5 continents or so. But what I can say is RPI is the best. I'm biased, but then this is really true, honest opinion. RPI is the best. Why? Because of the history, researches, and most importantly, people. I really feel that all civil and environmental engineering professors and staff are very, very close and a part of the RPI civil and environmental engineering family. Good university. I'm not criticizing anyone. I'm not specifically stating any universities, but the great universities, professors from great universities, not necessarily get on, but we are really getting on. We celebrate birthdays together, and we cry together, we laugh together. So we very like close family, And this is why I'm here, and this is why I'm very, very happy to be here. So this is why RPI is the best. So if you come here, you'll become part of our civil and environmental engineering family. And I'm looking forward to, we are all looking forward to welcoming you and becoming part of family here. Thank you very much.
Perfect. Thank you, Dr. Yachuda. That was wonderful. I know I always learn a lot from these presentations. Could you put the slides back to the email slide just so that the students can kind of screenshot that? Perfect. We have a couple of questions. I've answered a few throughout the presentation, but we do have one. Do students in civil and environmental collaborate with students in other engineering majors?
They do, the first and second year engineering students, you have to take what we call core engineering courses, such as Intro to Engineering Analysis, what we call IEA, or Intro to Engineering Design. And these are the designed for you to collaborate with other disciplines. So you have lots of opportunities to work with them as well, yes.
Yeah, and we do have Dr. Letchford here, the department chair for Civil Environmental, joining us as well. So he's here as well to help answer some questions. I'll answer this one quick because it's a quick one for me. Is this PowerPoint posted somewhere? The PowerPoint isn't, but all of these webinars are recorded. So within a couple of weeks, just because there can be a little bit of a backlog with the amount of webinars we do, this will be put on our RPI Admissions YouTube page, and the civil engineering and environmental engineering webinar that was completed for accepted students. So we'll probably have a little bit of a different feel. It's on the YouTube page already, so you can go ahead and take a look there. Here's a good one. How is funding for research opportunities provided?
Thanks, Kevin, for the very specific questions. Well, this is our job. Professors writing proposals and then try to get funding from agencies, national or international agencies. I personally got the funding from Department of Energy US, and also part of the equivalent Department of Energy Japan as well. Chris, do you want to add?
Sure, thanks, Sean, and thanks for doing the seminar. I'm very disappointed that we can't do this in person, obviously, because I really enjoy meeting parents and prospective students. And if I may take a moment or two, typically I give a spiel where I talk about really only two decisions, big or small, near or far. And in terms of undergraduate education, I'm always a recommender for far away from your home and a small location, because we are a relatively small school, about 6,000 students, mostly engineers, or 2/3 are engineers, and all very much focused on really a single purpose, getting an engineering degree from a top-notch university. And far, I think it's a great time for students to grow up and experience a relatively safe environment for maturing, which happens a great deal in those 4 years that we see students. So there's the sort of two choices, near or far, big or small. I think if you're contemplating graduate school, then a big school is often better because you'll have more choice. But for undergraduate, I think the treatment that you'll get in a smaller school like RPI is fabulous. And as Sean has indicated, civil and environmental engineering is a family. I teach our students, civil and environmental engineering students, both in the second and third year, and so I get to know all my students. Nobody can hide in my department, so I get to know all of you, and that's really important to me as head of department. And when you walk across the stage in 4 years' time, I will greet you by your name, and that impresses our dean immensely. But as I say, it's really important that you feel that you're at home. When I do exit interviews of seniors, the thing that they always tell me is, I wish I'd learned to ask for help earlier, and please take that as a mantra. Do not be proud of not asking for help. It's really important that you do that. There are lots of opportunities to do that, particularly with the professors and the TAs who are really dedicated to having you succeed. And as I say, it's a sign of strength to admit that you don't know something or you don't know how to do something. And that's what we expect our students to do when they graduate. We don't expect to teach you in 4 years what you will use for 40 years. It's just not possible. So you're going to have to teach yourself a lot. And the best way to learn something is to ask questions. And so please use these 4 years as an opportunity to ask lots of questions. And in my view, there are no silly questions, maybe silly answers, but never any silly questions. So in terms of, I think the question was related to
research funding.
Research funding. Yes, that's largely up to the professors to get support, but the Institute is very generous as well. It usually provides half the funding for undergraduate research opportunities. So if you are interested, we can always find some funding even for fund professors who haven't been successful at the moment. With Institute funds and departmental funds, we can help with research.
Awesome. This is a good one. How difficult is it to balance student life, sports, and being part of civil engineering? I'll answer it. I'll start it because I work very close with many of our students. It depends on the person. It really takes a very dedicated, time-managed person to be involved in a ton of different things. So if you are good at time management, I think you can start out right away. But I think it's a skill that all RPI students learn is time management. And I don't know if my colleagues in engineering agree or want to say something else in regards to that.
I agree with it, Greg. Yes.
Sure.
But then civil engineering is, if you, like I said, civil engineering has 4 different disciplines. Even within civil engineering, we have transportation, environmental engineering, and geotechnical engineering. So that's all like a student life in a sense. So you need to know what others do. So becoming a very, very good civil engineer is same as becoming very, very good at socializing as well. So I think if you are very dedicated to student sort of fun part and then doing lots of sports, it's also very, very helpful to be a good civil engineer. So I think it's sort of a right balance in a sense. But then especially civil engineering, you can have lots of social importance because term civil is people. So you need to have these interpersonal skills to be successful in our field.
Can I thank you, Sean, and I agree completely. Can I also add that I am a firm believer in civil and environmental engineering providing common wealth from which all individual wealth is built upon. So we provide water, transportation, sewerage, buildings, all of the things that we take for granted in a first world quality of life are provided by civil engineers. You would not get electricity without civil engineers building power stations, building transmission lines. You would not have water supply without civil engineers building dams and building water distribution systems. You would not have communication systems without communication towers, etc. So we feel very strongly that we are very well connected with community, and we provide the commonwealth that builds individual wealth.
Awesome. Yeah, and the next question might be a good one for you, Dr. Ledford, is do students, because you're in structural engineering, but do students in civil collaborate with the School of Architecture at all?
Yes, we do. We have a fantastic program in the 4th and 5th year. So if you stay for the co-terminal degree, we have the Bedford program where students do 3 specific courses with architecture students, the Conceptual Structural Systems, the Bedford Seminar, and the Bedford Studio. The Bedford courses are taught by a professional structural engineer, typically coming from New York City. And those courses lead to collaboration between engineer and architect. I teach Intro to Structural Engineering in the 2nd year, and that's usually taken by architecture students securing a civil engineering minor, and usually about 10% of that class are architects. So we see them in 2nd year, and then if you're really interested, the Bedford program is perfect for those blending the interest between civil and architectural, or particularly structural and architectural engineering. And in the past, this has culminated in a 10-day trip somewhere in the world to look at great combinations of civil and architectural practice. So we did not go anywhere this year, obviously, but last year we went to Brazil. The year before we went to Japan. We take 6 engineers and 6 architects and 2 professors to look at these examples of great combination, great practice together.
Awesome. And then I sent one question through before we were done that one. What type of research projects have civil and environmental engineers recently worked on?
It's a professor orientated. So each professor's got its own project. One of my undergrad research we did a year ago was about soil barrier for nuclear power station or nuclear waste disposal. That was a project, yes.
Some of the other projects include the use of or recycling of plastic bottles into temporary housing in disasters. So typically water is in short supply after a disaster. Water is shipped in plastic bottles and then recycling those as structural elements. So one colleague's had a couple of students, engineering and architecture students, working together on how to build beams and columns out of plastic bottles. Our transportation group do a lot of work on data analysis and data reduction, particularly on freight and delivery systems. And clearly that's gone through the roof in the COVID era, where everything is typically delivered by Amazon, UPS or the postal service. So managing and understanding the best way of delivery is another big project that our transportation group on. Sean talked about geotechnical, environmental engineering work on a number of issues related to air and water pollution. So there are opportunities in all 4 areas within civil. In my own area, I'm a wind engineer, so I look at wind loads on structures, and I have used undergraduate researchers in the wind tunnel, collecting data and helping build models for our experiments.
Awesome. What are other opportunities for students to participate in internships? And the answer is yes. The general answer is yes, absolutely. Do you have any specific examples of some of the places where maybe the civil and or environmental engineers have gone?
Chris, yeah.
Sean? Yeah, okay. Well, it's never very difficult, typically, for civil and environmental engineering students to get internships, because I'll put it like this. I bet everybody in this room could name a mechanical or electrical engineering company, because they're huge. General Electric, General Motors, Boeing, or Microsoft, Google. All of these employ lots of engineers, typically not many civil or environmental. So there are a few very large firms in those other forms of engineering, whereas in civil and environmental engineering, they're typically much smaller enterprises with maybe 10 to 50 engineers. And so there are numerous opportunities with small firms all over the country. And we have had students work all over the country with internships. We have groups working right now, even in the pandemic, working with various companies, some remotely and some on site, because a lot of internships for civil engineering typically involve site work. And that has continued through this situation.
Yeah, and because of our long history, we have a very, very strong connection with the local and also nationwide as well. So I haven't met anyone who hasn't got opportunities to do internship.
Awesome. If anyone has any more questions, please feel free to send them through. I'm not seeing any more questions at this time. So again, if you have any last minute questions or any questions that we do have a little bit more time left scheduled. So feel free to ask those now. We've had a lot of good ones. I will ask one that I got, and I kind of went off of the entrance numbers, but kind of, can you talk about the size of the department and how many students are in, say, civil or environmental engineering in any one particular year or overall in the department?
Sure, I can probably answer that. We graduate between 80 and 100 students a year. It's a bit hard to measure how many are in the department itself, because there are various year groups and we formally only have you into the department in the middle of second year, when we have our 4 intro courses to the various stages. So I like to think of how many we graduate. We typically graduate between 80 and 100 students. So we're relatively small. You know, there are programs that would graduate 5 times that. And in New York State, Buffalo typically graduates at least twice as many as us. So they're a much bigger program. But we, as I say, I know all of my students, and we graduate between 80 and 100, mostly civil, so 3/4 civil, 1/4 environmental, and they are 2 separate degrees, 2 separate accredited, ABET accredited degrees. And you can do concentrations within civil that are, as Sean has said, structural, transportation and geotechnical, but also environmental with a civil degree, or alternatively, you can take a Bachelor of Science in Environmental Engineering itself.
Awesome. We did have one more question come in. How many projects do students work on while they're undergraduates?
I'm not sure. I mean, if it's talking about in a class, many of our classes have project bases. I know I teach 2 courses, structures and hydraulics and hydrology, and we have a project in each of those. Many of the classes now use a final project as a great way of reinforcing integration of knowledge and integrating of aspects of the course into some sort of design element, because engineers are designers. I often say engineers are MAD, M-A-D-D. They model, they analyze, they design, and then they document. And the only thing they get paid for is documenting. So it's really important that you can communicate the modeling, analysis and design, because without that communication, it'll never get built.
I've heard Dr. Kurt Anderson, who's one of the associate deans, use that exact same terminology. That you only get paid for the last one. We have a bunch of questions coming in, which is fantastic. Can you talk about an introduction to the math concepts involved in the department? Kind of talk about some of the math requirements and things like that.
Yeah,
Sean,
so math is very, very important for us. So you have to have math. We go through math 1 and math 2 as well, and it's very, very, it's core of civil and environment engineering, I'll say. Yes.
Our students, beyond the Calc 1 and 2, as Sean said, they often take, well, they have to take differential equations, and they'll often take multivariate calculus as well and get a math minor. So maths is important. Math is our basic lingua franca, that is to say, everything we do is mathematically based. That's how we make decisions without just feeling about them. We calculate them. I'm fascinated with the people on the list here from Georgia and Florida.
All over, yeah.
All over, fantastic. It's we have a lot of students from the South who obviously want a change of scenery in their school years, and a lot from California who also get a lot of scenery. So welcome everybody. It's great to see such a variety of people here.
Yeah, and then this is a good one too, talking about the diversity at the school and in the department. But is there an equal representation of men and women in engineering? Now, overall, we have about 32% female in the School of Engineering, but it varies widely from department to department. Biomedical engineering, for example, is 60% female. Aeronautical engineering is 80% male. So it does vary widely. What about civil and environmental?
So we have 1/3 women in civil and probably 2/3 women in environmental. So, I mean, only 3 years ago, it was 50% women in civil engineering, which was amazing and great. You know, there's every possible career opportunity in civil engineering, from in the office to in the field, from design to construction. And so, you know, there are every opportunity. There's no real problem with diversity opportunities in civil engineering and environmental engineering. My own cousin in Australia, she graduated with civil engineering and then got very keen on road building, and so joined the Department of Transportation in my state, and is now a senior engineer manager in in that position. So she's thoroughly enjoyed being on site and managing big teams of construction equipment and people. So it depends on your own interest, but there's no problem. We have 3 women faculty and 16 faculty, so we're roughly a third in terms of women on my faculty. And the hope is that we would increase that into the future.
Perfect.
My faculty is the only faculty in the School of Engineering, and I would suggest this whole institute, that has a person from every inhabited continent. So we have 5 different continents represented in our 16 faculty, and that's unique to RPI.
That's fun to know. That's a stat I'm going to keep for myself when students ask. I did have a question. There's a question about specific AP exams. I put the link below the question right in the chat, so you can see what our AP policy is, and that's right on the admissions page. This is an interesting one. Would you prefer students to do research at the undergraduate level or an internship? Or what do you think employers would want? It's kind of the better question.
So personally, I would always encourage you to get an internship to explore the career options that you might like. I mean, many students come into engineering not really having a very clear idea of what they think engineering is or what this particular branch of engineering is. And so we really encourage our students to get internships, typically in the summer, although with Arch it's now in the fall. So yes, it's a great idea to get an internship just to explore the variety that is civil engineering. So indoors or outdoors, construction or design. You know, there's a lot of work in renovation now too, so a lot of site surveys and that sort of thing. So I mean, I think the opportunity for research exists during a teaching semester. And if you really get engaged in that, then maybe take a semester instead of interning and doing research. That would have to be paid. But I personally think it's much more important to get internship experience to explore the variety of civil engineering that's possible.
Yeah, and then the question just came in about co-ops, and I know I tend to sometimes use internships and co-ops interchangeably, but the work experience in general can be very beneficial. This is a good one. Is there testing after graduation to become certified as a civil or environmental engineer?
Yeah.
Yes, sure.
So this is probably why you need to do civil and environment engineering degree. In order for you to open civil environment engineering company, you have to certify, and which is PE, practice engineer. Professional engineers, yes. So you take the exams. So we started with fundamental engineers, FE exams, and then we tend to teach, or one of our colleagues teach how to pass those, how to do well on those exams. So about 1/3, I think it's about 1/3 of the students who get FE before graduating here, yes. And then with the 5 years of experience, you get PE, yes. Afterwards. Yeah.
Sure, and typically, like Sean said, we have one of our honour societies runs review sessions for the FE exam. I guess we should say or reiterate that really PEs are almost uniquely civil engineering, because we are dealing with the community at a level where you need lawsuit protection, because if you work in a big company, they will look after you. If you work in a smaller company, then you need to have your own protection in a sense, and that's the PE, or that's the protection for society, that the engineer is doing work that they're qualified for. So the FE is the first stage, as Sean said. Most of our students take that before they graduate. And then if you do a master's degree, 3 years after that, you can sit the PE license exam, or 4 years or 5 years if you're you just do the bachelor's degree. And it's to own your own firm, you'd need to be a PE. Many design like PEs simply because then they can stamp drawings and get their own work and become basically their own bosses.
You know, kind of talking about that master's, is it possible to get the graduate degree in 1 or more years of study?
Yes, we've integrated the bachelor's and undergraduates into a fairly seamless 5 years for most people. Many of our students come in with AP credit and take a few extra credits along the way and can graduate in 4.5 years. There have been some very brave souls that have done both degrees in 4 years because they came in with maximum credit. and chose to not have a life but just study. This is not what I recommend. I have never thought of education as a race, so it's not what we recommend. 4.5 is fine because you get an extra summer for interning, and that's often used by employers to see you as a graduate, effectively undergraduate, see how you're performing, and then you come back for another semester to finish your master's, and often you are working in that semester with the firm if it's local. So you know, it's a very good stepping stone to a professional career, the coterminal master's degree. And as I say, often done in 4.5 years, but 5 is norm.
And then an additional kind of question, does the 5-year master's include the arts? And the simple answer is yes. Yeah, every program on campus includes the arts besides our accelerated medical program, because they're only on campus for 3 years. Do engineering students take classes in the humanities? Yes is the answer. You have to take 20 to 24 credits. I don't know what it is in civil and environmental. I'm using my admissions jargon, but in our School of Humanities, Arts, and Social Sciences before you graduate. And those are very, very flexible.
Most of our students, if I can add, Greg, most of our students do a minor, typically in economics or psychology. Again, great areas to minor in if you're going to practice in society, understanding the flow of money and understanding how people work. Economics and psychology, really valuable minors that many of our students take in their house requirements.
Awesome. This one is about dual degreeing. What a dual major look like? I'm assuming the student's asking between civil and environmental engineering. And is it possible, and would you advise it?
Well, so everything is possible. Whether it's advisable or not is another matter. Personally, I think the undergraduate degree should be as broad as possible. And then you should do a second degree if you wish, but that should be concentrated. So I see really little point in 2 undergraduate degrees. I see a broad undergraduate degree in civil with maybe a focus in environmental, if that's your bent, and then a master's degree and an MEng, a Master of Engineering, in one of the 4 areas of civil. And that's much more valuable to an employer, that you've gone into more depth in a specific area, but that you have a good background across the whole breadth of civil engineering. So we have some people doing dual civil environmental. They're tough because if you can appreciate this, civil engineering is really predicated on physics as its main science, whereas environmental engineering is clearly predicated on chemistry and to a greater extent biology now. So, you know, they are somewhat mutually exclusive as sciences. And so to do both undergraduate degrees, you need to have a lot of chemistry, biology and physics. Whereas one or the other, it's just a smaller component of either physics or the chemistry, biology. So I think the best thing is to get a broad undergraduate degree, and a civil engineering degree with a focus in environmental would be such a degree, and then get a master's in something that, you know, really piques your interest.
Yeah, and is there a dual major that kind of works the best with civil? Or, you know, we always hear about building science in the School of Architecture. Is that one that it could be a possibility as well?
I mean, we have a couple of students who minor in building science. Clearly, that's an area that's of real value to the society, particularly with the fact that we have probably 90% of the building stock that will be around during this generation's lifetime, the next 50 years. So there's a lot of opportunity to explore our existing building stock and improve it, and building science certainly helps that. The architecture school is a little difficult to work with in terms of timetabling. They tend to operate on a slightly different timetable. So I know students do experience problems doing architectural minors. It seems much easier for architects to do civil engineering minors. So I mean, there's every opportunity to do that. And I've known students who've taken courses and even minors. There's a very successful acoustics program in architecture. And I know a couple of civil engineering students who've done the minor in acoustics. They were musicians, and so they were particularly interested in music and sound, and they did the architectural minor in acoustics. And that has a great job prospects in the design of, you know, interior spaces for sound transmission.
Awesome. And then this is the last question I have in the queue right now. So again, if you have any more questions, feel free to send them through. But I think if this is the last one, it's a good one to end on. Do you believe the civil engineering program at RPI is one of the most intensive and comprehensive compared to other universities?
Intensive,
Yeah.
yes. Well, in general, well, compared to other countries, yes, I've been to, yes. The US university is very, very intensive. Comprehensive, definitely, yes. So the answer is yes, I believe, yeah, our program is very intensive and comprehensive. And we graduate good students as well, so you become part of our family.
Yeah, no, I have taught I've taught only on 3 continents. So Shun, I visited 5 continents, but I have also only taught on 3 continents. And you know, RPI, and I've taught in public schools and private schools, big schools and small schools. And I'd have to say that I've enjoyed almost the last 10 years here at RPI, simply because we have great students. We're in a great part of the country, in my view, having lived in Texas before. Sorry if there's any Texans on the line, but upstate New York is a beautiful part of the country. We have great students. We have a fantastic program, you know, as comprehensive as any undergraduate degree. The variety is the same as you'd expect in any undergraduate degree. And in our own expertise, our colleagues have been nationally and internationally recognised. So they are leaders in their fields.
And we're the oldest. That helps too. I know you talked about it earlier. It was our first degree.
Yep.
If you've been to a carnival and you've been on a Ferris wheel, you can thank RPI for that wonderful education. And I think, again, if that don't see any more questions coming in, I think it's a great one to end on. Dr. Letchford, Dr. Uchida, thank you for taking time out of your day to talk to our students and our prospective students and give them a lot of great information about RPI and our civil and environmental engineering department.
Greg.
So
thanks everyone for tuning in.
Thank you, Greg.
Thank you very much.
Yeah, absolutely. So everyone enjoy the rest of your day and have a good end of your week, good weekend, and stay safe out there.
Bye.
Bye.